Okay, just a few more words about the solar tracker components and how they are manufactured and what they mean. You have 8, I think these are 3 16th inch dowel rods, and each one is, I think, about 34.5 centimeters. 34.5 centimeters, which is 13 and a little more than 13 and 5/8 inches. So each one of those is just by a 36-inch dowel rod. Take a kitchen knife, measure off that distance, and then once I marked one of them, I just put them on the table with a knife and rolled it back and forth a little bit, and snap, come apart. And I took the kitchen knife and I whittled the ends a little bit, just to give them a little bit of a taper, and then I whittled the very ends even more, so they kind of like tapered in a little bit, and then at the end they actually kind of nose in, makes it a lot easier to get through the holes. The hula hoop parts are, again, very simple to assemble. Buy these on Amazon. And by the way, you get dowel rods at, Michael's, Hobby Lobby, probably Walmart, wherever. Then the hula hoop I bought on Amazon. You get a 6-pack of these. 8 of them makes one hula hoop, so you get 48 of these sections. So I put them together. I drilled holes in them. First at 45 degrees angle this way, 45 degrees angle that way, so that the sticks will go through. And I offset them slightly. The reason for the offset is so that they don't hit each other. Those ones kind of hit each other just a little bit. There we go, got past it. But that's okay, it just creates a little bit of a tension in them, and then as they go to the 2 pieces. So actually drilled through at the joints at 12, 6 and 6, and 0 hours midnight. So 0, 6, 12, 18. And I drill through where there's a joint, making holes in both of them at the same time. The blocks also are just those 1.5 inch blocks, 1 3/4, not sure. Took and drilled halfway through, not all the way through that one, and then all the way through this one, and then 4 holes, each coming in at 45 degrees. Very simple. 1, 2, 3, 4, and again, making sure these are snug. I have a set of drill bits that go in 64th inch increments, so it was easy to continue to find one that would keep it snug. And so I started with small ones and then just increased until I couldn't quite get it in. And then the next one up, I just drilled part way in, not all the way in, so that at first it starts to go in and then it's perfectly snug. It doesn't have to be hard to get in, just you want it snug. The other one, you want to be able to go obviously up into position and still have friction, so you don't want that too loose. So that's nice, having a little bit of tension on that. Then finally, well, you also have a 4-inch styrofoam ball. You could use a 3-inch ball, even 2-inch if you wanted, but then you would just have to adjust for your center. Center is still going to be here, but then the markings would move down. The markings here are marked to match this ball, so that when it's in the equinox position, the first marking here is for equinox to solstice and back to equinox. On this side, equinox, solstice, and back to equinox. So the ball moves with the dates. I've got the south of the equator side. I've got the north of the equator side. The north of the equator side, where I'm living currently, in the winter time, the ball starts rising up. So October 3rd, October 13th, is that 18th? October 28th, November 5th, which is today. Again, happy election day. So that's where the ball would be for today, all the way up to 23.5 degrees relative to the hoop, as explained. But the point is that the markings here, I've got north of the equator, dates going up to December 31st, back to equinox, down to June 21st, summer equinox, summer solstice, and back to equinox. The southern hemisphere side is exactly the same, except this goes down to December 31st, back to equinox, and then up here to June 31st, winter equinox in the, if you're south of the equator, and back winter solstice, summer solstice for them. No, that's winter solstice in the south. So very simple. It's the same, basically the same as if you start at the North Pole and you want to start with your, you're at 90 degrees north, so henceforth you got 90 degrees latitude angle, and as you start going to the south, you go farther and farther south. So if you get to, let's say, where is it? 60 degrees, that's what that's at. So if I'm in Iceland, which I will be in a couple weeks, I will set this to 60 degrees. If I'm a little farther south in Brussels or Paris, or if I go all the way down to my current location in the United States, which would be right about there, 39 degrees, then I'm at that angle. But as you keep going south to the equator, you actually have to kind of hold it sideways, not stick it in the ground. So at summer solstice, or at equinox, when the sun is going directly overhead, the hoop goes directly around, it rises exactly east, goes directly overhead, sets directly west. At the solstices, it's going to be off one way or the other, because if it's at the Tropic of Capricorn or at the Tropic of Cancer, then the angles are different. But then, of course, if you keep going south of the equator, well, then you'd have to keep going like this, and the pointy end would be up. And so that's not convenient. So you start going south of the equator, you just flip it around, and then just keep going south, and then you use the side that says south of the equator, so the dates are flipped around. And as you keep going south, you want to say, let's say you're going down to Chile, where you're now 60 degrees south. You set your angle to 60 degrees. You can check and see if the sun simulator works. If you say go all the way down to Union Glacier Camp, where you're at 80 degrees south, and you set this for 80 degrees, you check your angle, and now you point this directly to the south with the stick bottom pointing north, and your sun simulator should match all observational movement of the sun, and then you're good to go. That is how you make this. Super easy. Took me no more than a few hours. I worked out the table of the sun declinations. I'll provide that somehow, and very easy to mark it onto here. This is from 0 to for a 23-inch hoop like this one. It worked out that every 4 degrees was about 20 millimeters. It started to compress, stretch out a little bit at the end because the tangent function starts to go nonlinear. But at the winter solstice of 23.5 degrees, it was at 123 millimeters from the equinox point. So I think it was 20, 40, 60, 79, 98-ish. The 22-degree mark was 114 millimeters, and then the last one was at 123 millimeters. That's all.